Let's look at the create method in the customer order DAO. First, let's look at the interface of the create method. Notice that the create method does not have a parameter for the primary key field, nor does it have a parameter for the date created field. Both of these data are automatically generated by the database when a new record is added to the customer order table. As mentioned in the last slide, the primary key is returned because we need it for use in the line item create method. One other interesting thing about the signature of the create method is that it takes a connection, which leads us to ask, why pass in a connection instead of declaring it as a resource in our implementation? This is not an easy question to answer, but I'll give you 5 seconds if you like to pause the video and think about the answer. 5 seconds starting from now. Okay, so here's the answer. The connection needs to be passed in externally because all the create methods used in this transaction need to be using the same connection. That connection will allow the create methods to effectively reserve a row in the database without committing it. Once all rows have been reserved, the data is committed, and the database will ensure that everything is committed or nothing is. It's important to note that having a connection object in the signature does break information hiding, meaning that it reveals the fact that you are using a database that requires a connection. Now, since all JDBC compatible databases require a connection, you're not giving too much away here, but it's still something you should be aware of. Here's an outline of the create method for the customer order class. Notice that the SQL string has 3 parameters, 1 for each field value. The try with resources statement contains 1 resource, the prepared statement. The statement is initialized based on the SQL string. The 3 parameters need to be set before the statement can be executed. Instead of calling execute query, as in the find methods, here we call execute update. This handles SQL insert statements. The SQL update method returns an integer that represents the number of rows in the table affected by the call. In this case, if everything goes well, we expect that exactly 1 row will be affected. If the update has been executed successfully, a result set is obtained that contains all the rows corresponding to all the keys that were generated. In our case, only 1 key should have been generated, so we get that key from the result set and assign it to the long integer that we will return. Notice that if something goes wrong, 0 is returned. If everything goes well, the primary key for the row we added is returned. Here's the complete create method. As noted in the slide, nothing is committed until we commit everything associated with this connection in the placeOrder method. Let's take a look at the placeOrder method now. This is the signature for the placeOrder method and the getOrderDetails method. PlaceOrder carries out the transaction initiated by the submission of the form on the checkout page, and the getOrderDetails method returns all of the order details needed by the confirmation page. Notice that the placeOrder method essentially takes all the information from the checkout page form in addition to the shopping cart. Here's the implementation of the placeOrder method. The DAO objects are needed because we need their create methods. The placeOrder method simply gets a JDBC connection and calls through to the perform placeOrder transaction method. You might wonder why the application context is not used to initialize the DAO variables. We generally restrict the use of the application context to the presentation layer. Using it here in the business layer would lead to unnecessarily coupling between components. This method is where the key transaction code takes place. There are three important aspects of this code. First, look at what's happening with the connection object. At the beginning of the method, we set auto commit to false. This means that nothing we do gets committed until we explicitly call the commit method. We call it just before the code returns. Now, if something goes wrong in the try block, we call the rollback method on the connection. The rollback essentially cancels all of our reservations. We're no longer committing anything. Now, the second thing to notice is that we're calling three different create methods. One from the customer DAO, one from the customer order DAO, and one from the customer order line item DAO. The line item create method may get called multiple times depending on how many products we ordered. Note again that the customer create method and the customer order create method return keys, while the line item create method does not. Finally, if everything goes well and the data is committed, the customer order ID is returned. If something goes wrong, 0 is returned. Recall that 0 cannot be a primary key. And that's it for this video on the DAO pattern and transactions. I hope it gave you a better understanding of how JDBC DAO classes are implemented and how transactions work when using the DAO pattern. I'll see you in the next video.